Okay, so I want to talk about a special case here that I call select backfill or structural backfill. And it's the case where we have a retaining wall with some footers at the bottom that extend out beyond the extent of the wall. And in the real world, we are going to dig the whole trench there to include the width of the footers there. But some people say, well, I'm just going to use unclassified cut or fill material to go back in beyond that. So I want my cut line to come down along the face of the wall. But really, the same rules applies for our cut and fill meshes that apply for our terrain algorithms, which is there's no ability to do overhangs or tunnels in them. If we have any kind of overhang, it uses just a vertical face there. So to show that here, I'm going to run the create cut fill volumes on this section that has a retaining wall on it, and we'll see what it does. It goes from the existing ground down to the bottom of any design component that it sees, and so that creates us a vertical face there. And then when it runs out of footing over here, it goes vertically down to the next design feature. So this is good, this is correct. But how do we quantify this area here, which is not cut? We do need this material quantified. And to do that, we're just going to create components in the template that handle that case. So I'm going to switch over to corridors, and I'm going to edit this template drop, and we'll put those in there to quantify that for us. So the material that's on the inside of that retaining wall is easy to model there. I'm just going to add a new constrained component. I'm going to snap to all the existing points. This is easy because it's not looking at the existing ground surface, so it never changes. So we're just going to model it there and say finish. So really this point we would want, let's insert a point here. We want that to be over here, and we want that to be vertically and horizontally constrained to the point below it. So we'll change that real quick here. Horizontally constrained to the bottom of the wall at 0. And then vertically, we'll just say that's going to be the same as there, at 0. Okay, so that handles this backfill on the inside here. And the backfill on the outside, we're going to want it to go up and find the surface. So what I'm going to do is add a new in condition component that goes up vertically and finds that surface there. So I'll say finish on that. I'm going to make sure that this in condition is infinite, so it'll find the active surface. And then our component then, add a constrained component, is just a matter of tracing that wherever it finds existing ground, and it's going to go up. It could go beyond the wall there, so I'm going to say finish, or it could go beyond or below. And on this point, I'm going to edit it, and I'm going to make its vertical constraint a project a surface, so it'll just go and find wherever that surface is, any direction to the active surface. Say apply there and close. We're going to test that real quick before we leave to make sure that it is drawing a component for us, and it is. That looks good. And when we say OK on that, we look at the components drawn here in our cross section. We can see that the select backfill on the inside and the outside of the wall are now going to be quantified, so that when we go and run a volumes report there, we can get that amount of material that was cut out but needs to be replaced as well.